Hello students, this is a support video for assignment 2. As usual, my recommendation would be to start by reading the assignment 2 notes and then you also have a template available to you and an assignment outline. So the four things together, the video, the assignment notes, the template, and the assignment specification would make it easy for you to tackle the assignment. Now we are building up on assignment 1 where we had constructed a vector abstract data type. We sorted using selection sort. The sorting was done according to chart position. And then we also wanted to do, that made it efficient because, that made it easier for us to pick the top 10 songs. So in that sense, sorting according to chart position is useful. It also makes it useful for us to be able to insert and delete elements from. Hello students, this is an overview video for assignment 2. As usual, please be sure to read the notes, which will give you an overview of what we are going to do and why we are moving upwards and spiraling upwards in this assignment application. So notes plus template plus the assignment document and the video should together be a good support for you. What we're doing here is building up on the vector abstract data type in which we were creating a vector of songs, and a vector potentially offers us unlimited size, so we can insert and delete in any position, something that's difficult to do in an array. And we were also able to resize the dynamic array to give the illusion that the vector can be of unlimited size. We also noticed how the push back and pop back operations done at the end require a different amount of work from inserting and deleting in the middle. We also did a selection sort on the basis of chart position, so we could quickly get the top 10 songs. But we had this need to search songs by title, which is typically what happens when a user sends in a request. They want the DJ to play or the RJ to play a particular title. So, and what we then ended up doing in the last assignment is to do a linear search. And because it was not sorted by title, we were ending up, as you may have realized, doing a lot of work trying to search. So now we are trying to upgrade this application by saying, well, what if we wanted to do a binary? We wanted to upgrade our search and make it faster, because this searching for titles is something that we are going to be doing frequently. Well, then in order to improve our search by title, we need to sort by title. And so this looks now like we are going to need to do more work because we have already done one round of sorting. We need to keep that because we quickly want to get the top 10 songs. We have also done a lot of work inserting and deleting and working on the on the vector by chart position. So we would like to stay with that part of the application. So then one possibility then, which we're going to work on in this assignment, is let's do another sort, take the database and sort it according to title, so that then we can improve our search. So we are going to, in order to improve our search to give the user a fast service, we are going to do now two searches. The first one is going to use the function object less than. The second one is going to use a function object that is called less than equal to, right? So here's what all of this stuff is given in the notes, that we are going to sort the database twice and using the same selection sort. Now this is going to increase the complexity, or it's going to add some more complexity to our implementation, but our searching, which is going to be done frequently, is going to be binary search. So the tasks that we have, so let's jump into the template now. So the tasks that we have are, if we look at the vector ADT and look at what we need to do, we've got to implement the binary search. And and we also have to implement a selection sort by title. Now, we are going to keep the original. So two things. We are going to keep the original database as it is and make a copy of the database so that we can do the second sort. Now, when we copy the database, we need to have what is called the copy constructor. And so this is a copy. This is what the header of the copy constructor looks like. It's going to have an input, which is the second database, and it's copying this database. It's going to copy from the other database into this database. What does that look like in the main program? Well, in the main program, which you do not need to change, everything has been written for you. So here's what is happening. We are going to make a copy So in the main program, we are going to make a copy and say, create a backup which is equal to the current database. When we use the equal to sign this way, this is when the copy constructor kicks in. And what the copy constructor does is it creates a new dynamic array and copies from database into backup. So you do need to write that. Another thing that's happening is we are using a second functor so that we can sort the backup according to title using the same selection sort. So two selection sort procedures. One is going to sort by chart position, the other is going to sort by title. So the tasks are write the binary search, write the copy constructor and destructor, use the second functor to do the sort. And also, in addition, what we're going to do is write two methods in the main program called adjust insert and adjust remove. These two methods are needed because the last time when we inserted into the database, if there was a duplicate chart position, then we did not take care of a duplicate. If there were two songs with the same chart position, we did not take care of that. And also, we were allowed to insert pretty much anywhere we wanted. And then that caused the database to get unsorted. So what we are going to do in adjust, insert and adjust remove is once we insert a song, let's say in position, in index position 4, which means chart position 5, then the one that previously held that position is going to be right adjusted, and therefore its chart position is now going to move from 5 to 6. And then the one that was on 6 is now going to have to move to 7. So cascading all the way to the end so that any insertion now does not unsort the database, but you will find that from the beginning to the end, the chart positions have been adjusted. So you do not need to adjust the ones before, but only the ones after. And the same thing for remove. When you remove, then there's a gap that's created and the songs are going to be pushed left and the chart positions are going to get decreased. So these two methods have to be written in the main program, and the binary search needs to be written, and then you need to write the copy constructor. These are the main tasks. Otherwise, you can leave the main program as it is. Once you're done writing these two methods, you don't need to make any changes to the main program. So all the templates have been given to you. The expected output has been given to you. When you run it once with the song data.txt, then you run it a second time. So here is your output using the selection sort. You print the sorted data. And because you don't need to change the main program, you don't need to, if all your methods are working fine, then your output is going to look exactly like this. So this is your output selection sorting by chart position. You see how when you double the size of the database, the number of steps increases. So you will do pretty much the same observations, and you will need to write a reflection on how making these changes, how has it affected the efficiency of our application in terms of sorting and searching, and also think about how expensive it is actually to do an insert or a remove to a vector ADT, right? Because it appears to the user that you can easily insert and remove, but how costly is that operation? So, so this is what you will write in your reflection.